Hi guys, welcome back to another video. Today's question on arrays topic is number of pairs. The question states that given two arrays capital X and capital Y of positive integers, find the number of pairs such that x power y is greater than y power x, where x is an element from the array capital X and similarly y is an element from capital Y. So let's have a look at the examples. Let's consider example 1 where the size of array X is 3 and the size of array Y is 2 and the array elements are 2, 1, 6 and 1, 5 for Y. So we have three pairs here which are 2 and 1, 2 and 5 and 6 and 1. Since we have 2 power 1 is greater than 1 power 2, 2 power 5 is greater than 5 power 2 and similarly 6 power 1 is greater than 1 power 6. Let's consider the second example where size of the array X is 4 and the array elements are 2, 3, 4, 5. Similarly, size of array Y is 3 and the array elements are 1, 2, 3. So here we can observe that 2 raised to 1 is greater than 1 raised to 2. So we got one pair. Similarly, for 3, 4, 5, we will get 3 power 1 is greater than 1 power 3, 4 power 1 is greater than 1 power 4 and 5 power 1 is greater than 1 power 5. So totally we got 4 pairs and we have another pair which is 3 and 2 since we have an exception that 3 power 2 is greater than 2 power 3. So what we can observe is that for every element in X, we need to find elements in Y which are greater than that particular elements. And the number of elements which are greater than that particular element, we have that many number of pairs. But there are few exceptions like we have seen in case of 3 and 2, 3 raised to 2 is greater than 2 raised to 3. So we will have the look at the exceptions while we approach this problem. Let's have a look at the approach to solve this particular problem. Let's consider the example 2 in the question where m and n are 4 and 3 respectively, where m is the size of the array X and n is the size of the array Y. The elements of array X are 2, 3, 4, 5 and similarly the elements of array Y are 1, 2, 3. So initially let's create an array or a frequency table whose size is 5 and which holds the count of the numbers 0, 1, 2, 3 and 4. So initially let's sort the array Y. Since it is already sorted, we can move further and update the frequency table. So the frequency array contains the count of 1 as 1, 2 as 1 and 3 as 1. The right side of the screen shows the algorithm to solve this particular problem where we traverse the array X from starting to ending and at each traversal we consider the element at x of I as val and then call the solve function. So initially I points to 0 and the variable val holds the value 2. So now we call the solve function with the value of val as 2 and then we declare two local variables namely position and result and initialize them to 0. Then we check whether if the value of val is 0 or 1. Since it is neither 0 nor 1, we calculate the value of position by using the STL library function upper bound which gives the index of the upper bound of that particular element. So we are finding upper bound for the element 2. So we get the value of position or pos as 2. And then we move further and calculate the value of result as result is equal to result plus n minus pos, which is the number of elements which is greater than val, plus frequency of 0 plus frequency of 1. Since for every element we have that particular element raised to 0 is greater than 0 raised to that particular element. The similar is the case in case of 1 where we have 2 power 1 is greater than 1 power 2. Similarly 3 power 1 is greater than 1 power 3. Therefore we are adding the frequencies of 0 and 1 to our result. So the updated value of result is 2. Now we check whether if the variable val is equal to 2. Since val was equal to 2, therefore we subtract frequency of 3 and 4 from result because we have an exception that 2 power 3 is not greater than 3 power 2. We have the reverse case, that is 3 square is greater than 2 cube. Therefore we subtract the value of frequency of 3 and frequency of 4 from result. So the updated value of RES or result is 1. And finally we return the result value. And after returning, we update the count variable by adding the value of result to it. So the updated value of count is 1, which means that we have one pair till now. Then we move further, and here the value of val is 3. And similarly we again call the solve function, where we declare two local variables, namely position and result, initialize them to 0, and we check whether if val is equal to 0 or 1. Since it is neither 0 nor 1, we calculate the value of position as upper bound in the array y with the value as 3. So in array y we don't have any upper bound for 3, therefore the function upper bound returns the size of the array. So we get the value of position as 3. Then we calculate the result as result is equal to result plus number of elements which are greater than val in y plus frequency of 0 plus frequency of 1. So we get the value of result as 1. Then we check whether if val is equal to 2. Since it is not equal to 2, we move further and check whether if it is equal to 3. Since val was 3, therefore we add uh, frequency of 2 to result. Since we have 3 square is greater than 2 power 3. Therefore we add 1 to result, and the updated value of result is 2. Now we again return result, and in the main function we add it to the count. So the updated value of count is 3, and again we increment the value of I, that is now I points to the third memory location, and the variable val contains 4. So again we call the solve function, declare two local variables, namely position and result, check whether if val is equal to 0 or 1. Since it is not, we directly calculate the value of position, which is upper bound of 4 in the array y. Since 4 does not have any upper bound, therefore value of position is equal to size of the array y, which is 3. Then we calculate the value of result as result is equal to result plus number of elements in y which are greater than val plus frequency of 0 plus frequency of 1. So we get the value of result as 1, and since val is neither 2 nor 3, we directly return result as 1. So 1 gets added with count value, and the value of count is 4. So till now we have got 4 pairs, and we move further where the value of val is 5. Call the solve function, uh, declare two local variables, namely position and result, and then we calculate the value of position as 3, which is the size of the array, and then calculate the value of result as number of elements in y which are greater than val plus frequency of 0 and frequency of 1. So again we get the value of result as 1, and since val is neither 2 nor 3, we directly return result value, and it gets added with count. So finally we get the value of count as 5, which means that we have 5 pairs in this arrays such that x power y is greater than y power x. So now let's begin with the code. So here the driver code is already given, that is the contents of main function are given. We just need to complete the count pairs function. So initially let's create a frequency array or frequency table of size 5 and initialize it with 0. Then we create a count variable and initialize that as well with 0. Then we traverse array y and update the frequency table. And if the value of y of I is less than 5, then we update the frequency table as frequency of y of I plus plus, and then we sort the array y, and then we traverse array x, and at each traversal we call the solve function. At each traversal we call the solve function, as well as we update the value of count as count is equal to count plus the value which is written by the solve function. So we can do that in a single line as count is equal to count plus solve. So the parameters to the solve function are the ith element of the array x, the whole array y, the frequency table, and the sizes of x and y respectively. So, and finally we return the value of count. So here we need to create another function which is solve. So the parameters of solve function were int val, as we have seen in the explanation part, then the array y, frequency table, and sizes of arrays. So now we can begin with the actual algorithm, where we create two local variables, namely position and result, and initialize them to 0. Then we check whether if the variable val is equal to 0. If the variable val is equal to 0, then we can directly return 0, since for 0 we don't have any elements such that 0 power any element x is greater than x power 0. Similarly, we check whether if the value of val variable is equal to 1. If so, then we can return the count of zeros in that particular array, that is frequency of 0. And if the value is neither 0 nor 1, then we can calculate the value of position as, so upper bound is a SQL library function which gets the index of the greater value than a particular value. So the parameters for upper bound function are the beginning and ending location of the array in which we need to find the upper bound, and the value for which we need to calculate the upper bound. So here we are subtracting the value of y, which is the starting address of the array y, and then we calculate the value of result as result is equal to result plus number of elements in y which are greater than val, which can be calculated as n minus position, and then we add the frequencies or the count of zeros and ones, that is frequency of 0 plus frequency of 1. And then we check whether if the variable val is equal to 2 or 3, since in that cases we have some exceptions. So we need to handle that exceptions, where if the variable val is 2, then we subtract the frequencies of 3 and 4 from result, that is result is equal to result minus frequency of 3 and frequency of 4. Since in case of 2 we have 2 power 3 is not greater than 3 power 2. Similarly, for 2 and 4 we have 2 power 4 is equal to 4 power 2. Therefore we need to subtract this from the result variable. And in case of 3, that is if the variable val is 3, we need to add frequency of 2 to the result variable, that is result is equal to result plus frequency of 2. and finally we can return the value of result. So we are done with the code and we can compile it to check whether it contains any errors. Since our code is compiled successfully, we can proceed further and submit the code. And our code got submitted successfully. If you found this video helpful, do hit that like button and subscribe to my YouTube channel for more such upcoming videos on must do coding questions for interview preparations. Thank you.